Using this Kleens theorem, we can convert from finite automata into regular expression. That is R I to j and power is k, means where I is initial state of finite automata, j is final state, and k is intermediate state. Means maybe finite automata with intermediate or without intermediate. Means from I to j we have to find from initial to final I to j, and power is k. Power k means there are intermediate state. If there are two intermediate, if there are two states, means k value is 2. Maybe one intermediate state or two intermediate state. Then I to j we have to find from initial to final. First, maybe in finite automata, maybe there is no intermediate state. If there is no intermediate state, means maybe k equal to 0. K equal to 0 or k not equal to 0. Means maybe there is intermediate state or without intermediate state. K equal to 0 means there is no intermediate state, direct path from I to j. Means there is no intermediate state. There is no k equal to 0 means there is no intermediate state. Maybe direct transaction I to j, with or without. But suppose within this, if I equal to 0, means k equal to 0 means maybe I equal to j or I equal to j, or I is not equal to j. I equal to j means maybe initial and final both are same. If I equal to say, then this is maybe initial and final both are same, q of I and j. I equal to j. I is not equal to j means this is q of I and q of j. Direct transition from I to j without intermediate. If this is finite automata, then again there are three possibilities within this, A, B, C. Maybe there is no input symbol. If there is no input symbol, then what is the regular expression for this? If there is no input symbol, R I to j power is 0, k is 0, R I to j power is 0 equal to, maybe there is no input symbol. If there is no input symbol and this is initial and final both are same, maybe phi or epsilon. We can take regular expression phi or epsilon. Maybe there is exact one input symbol. If there is one input symbol, then I to j power is k equal to one input symbol A, or can take epsilon R I to j. Maybe there is n number of input symbols. If there are n number of input symbols, then we can take A1 plus A2 plus up to A of n plus epsilon. These are the three possibilities. Maybe there is no input symbol, one input symbol, or n number of input symbols. On this side, maybe same, maybe one input symbol, or in no input symbols, or one input symbol, or n number of input symbols. If there is one in here, maybe there is no input symbol, means R I to j power is 0 equal to, if there is no input symbol, means you can take phi. Here you cannot take epsilon because your transition is from one state to another state. Then R I to j, if there is exact one input symbol, means A. If there are n number of input symbol, I to j power is 0 equal to A1 plus A2 plus up to A of n. Maybe there is no input symbol, exact one input symbol A, or maybe n number of input symbols A1, A2, A3, A4. Means regular expression either this one or this one, if k equal to 0. And if k is not equal to 0, means maybe there are intermediate state. If there are intermediate state, then we can find, we can design finite automata may be transaction from I to j with intermediate or without intermediate. This is simple finite automata. This is q of I and q of j, initial to final. And this is q of k, intermediate state, up to k, after k, or on k we can take self loop. But this transaction is up to this or on intermediate state or after intermediate state. Means transaction for this are I to k and here k minus 1 or k to k minus 1, and this is bracket to the power star. Here you can take n number of loops. Next, this side are k to j k minus 1, or you can take transaction from initial to final direct without intermediate. And if this is transaction means r I to j k minus 1. But here there are two possibilities. Maybe transaction we can take with intermediate or without intermediate. Means when if k is not equal to 0. Using this we can prove the formula. Which one? R I to j power is k equal to here this transaction, direct transaction or with intermediate. Direct transaction means this is R I to j k minus 1 or up to this. Up to this means this is R I to k minus 1 up to intermediate. On intermediate self loop means R k to k minus 1 and here bracket to the power star. Or next transaction from k to j. K to j means R k to j k minus 1. Using Kleens theorem, you can prove this formula. Using this formula, you can convert from finite automata into regular expression. In Kleens theorem, we have to prove this formula.